Alrighty, 7.1 Angles of Polygons. Now we're going to have a ton of writing in here, so you might have to pause it sometimes so that you can catch up. Starting off, a polygon, this is something that we probably already know. A polygon is a straight-sided figure. It's a figure with straight sides. So a rectangle would be a polygon. A circle would not be a polygon. A diagonal. A diagonal is a segment that joins two non-consecutive vertices. And a vertice is an angle. So what this would be, I can add some space in there, is if we had a shape, then a diagonal would go, well, as you kind of would assume, right, like that. If we had more sides, then you could have diagonals here, here. And then there's also ones coming out of each vertice. All right, next up, we've got 7.1, the polygon interior angles theorem. The sum of the measures of the interior angles of a convex n-gon is 180 times n minus 2, or times the quantity n minus 2. Now what this means is if you have some shape and you're wanting to know what the sum of the angles inside of it are, that would be like the angles that are here, you could plug in the number of sides. This one would be 5, so it would be 180 times 5 minus 2. Okay. Another word they have here, convex. Convex means that the shape, it's hard to think about. This shape here is not convex because a diagonal would go outside of it. So by being convex, you're saying that all diagonals are inside the shape. Okay, so yeah, this diagonal is outside of it, whereas the other shape here that I have on the left, the diagonals would all stay inside the shape. Right, the diagonals would all stay inside the shape. 7.1 corollary. Now, let me talk just a second about the difference between a theorem and a corollary. A theorem is like a math statement, a math idea that has been proved. Okay, a corollary is something that kind of builds off of the theorem. So 7.1 corollary to the polygon interior angle theorem. So it builds off of the 7.1 theorem. The sum of the measures of the interior angles of a quadrilateral, right, that's a four-sided figure, a four-gon, is 360. And we would get that by plugging in to that formula that we were given above. We would say, well, we've got 180 times 4 minus 2, which is 360. All right. All that theorem, or all that corollary is doing, is just plugging in 4. Okay. Nothing special, it's just plugging in 4. It's good to remember these names. It's also good sometimes to remember the number that goes with them. Okay, so make sure that whenever you are writing these down in your notes, that you actually write down the 7.1 part of it. Okay, write that down. Next up, we have some definitions for our polygons, some types. An equilateral polygon is a polygon where all the sides are congruent. An equiangular polygon is a polygon where all the angles are congruent. And then we have a regular polygon. That's a convex polygon that is both equilateral and equiangular. Okay. We could think about this, an equilateral polygon, all sides are congruent. You could think about like a rhombus. It's like a smushed square, right? The angles aren't the same, but the sides are. An equiangular polygon, maybe we could think about a rectangle, right, where they all have the 90-degree angles. And then a regular polygon, it has both equal angles and equal sides. We could think about a square. Okay. Next up. Oh, well, let me say this again. Equilateral, we're going to talk about a lot. Regular, we'll talk about a lot. Equiangular is one of those that we don't talk about quite as much, but it still is something that we need to know. 7.2, the polygon exterior angles theorem. an exterior angle is an angle that's exterior, it's on the outside. So if I were to draw a shape, and this is probably going to not be super great, okay, that's okay. And you extended these sides out a little bit. Oops. Kind of like that. Then what we're saying is we're talking about these angles here. Okay, those are the exterior angles, and I shouldn't really be putting dashes like that on them. We'll just like put a little dot to signify that we're talking about them. All right, what we're saying is the sum of the measures of the exterior angles of a convex polygon, one angle at each vertex, which is what I have there, is 360. No matter how many sides it is, it's going to be 360. They're going to add up to be 360. All right, those are our notes that we need to have here, and the rest of these are homework examples. So what I've done is I've gone through your homework and I've picked out some of the problems that we did not do, but are similar to problems that you will need to do on your homework, okay? Number one, find the sum of the measures of the interior angles of a 16-gon. That means a polygon with 16 sides. So we're talking about interior angles. The interior angle formula is 180 times n minus 2. So here we're going to plug in 16. 180 times 16 minus 2, which is 180 times 14, which let me find a calculator and type that in. That is going to be 2520 degrees. All right, next up, the sum of the measures of the interior angles of a convex polygon is 2520. Classify the polygon by the number of sides, okay? Now, I didn't really mean for these two numbers to match up, but we'll do it as if we didn't know that they matched up. What we're doing here is we're going to say, well, we have the formula 180 times n minus 2, and it's going to be equal to 2520. Right, we're trying to figure out how many sides it has. So starting off here, I'm going to divide by 180. So 2520 divided by 180, that gives me 14. So I have n minus 2 is 14. And then whenever I add 2, I'd have n equals 16. So it would be a 16 sides or a 16 gon, however we want to write that. All right, next up, we've got number 3. Find the measure of angle x and angle y. So we need to look at this shape here, and we need to kind of think about that. W is a 90-degree angle. I'm going to just write that in. X and y, they're marked as congruent. So what I'm going to do is I'm going to put like a little variable there. What variable should I do? I'll just do a little x for the variables there. You know what? I don't like x's. We'll do a different number. We'll do like w. I'm doing w because I don't like having, well, I don't like w either because I have an angle w. What's another letter? We'll do a there. There's nothing with an a there. So what we're going to do is we're going to first figure out how many or what the angles are going to add up to. In doing that, we need to figure out how many sides it is and plug into this formula 180 times n minus 2. Well, there are 1, 2, 3, 4, 5, 6 sides. So I'm going to plug in 180 times 6 minus 2. That's 180 times 4, which is going to be 180 times 4 is 720. Now that I have the 720, and this should be degrees, I can add these all up and set them equal to 720. So I can say, well, 99 plus 171 plus, there's two A's, so I'm just going to say 2A plus 159 plus 90 equals 720. Now I'm going to subtract each of the ones on the left, so I'll say 720 minus 99 minus 171 minus 159 minus 90. That gives me 201. Is that right? I thought that was supposed to be even. Let me type that in again. 720 minus 99 minus 171 minus 159 minus 90. Well, I got 201. So I'm going to say 2a equals 201. Whenever I divide by 2, I get a equals, well, this is going to be 201 over 2, or we could list that as 100.5 degrees. Okay. To check our work, I'm going to type these all back into the original guy. So I'm going to, in my calculator, type in 99 plus 171 plus 100.5 plus another 100.5 plus 159 and then plus 90. And in my calculator, I got 720, right? So that is what we said at the beginning we should have. Now to write our answer nicely, I'm going to say, well, measure of angle X equals measure of angle Y equals 100.5 degrees. And there we are. Number 4, find measure X, or find X. Now these are all exterior angles, and we have a theorem above, I think it's 7.2, that says the exterior angles always add up to 360. So what I'm going to do here is I'm going to say, well, 71 plus 85 plus 44 plus, well, I have 3x and then 2x, so I'll say 5x equals 360. Now I'm going to take 360 minus 71 minus 85 minus 44. That gives me 160, so 5x equals 160. And dividing by 5, I get x is 32 degrees. And there we are. Number 5, find the measure of each interior and exterior angle of a regular 45-gon. Notice here that it's not wanting the sum of the interior angles, it wants each individual interior angle. It tells us that it's a regular 45-gon, so each angle is going to be equal. So to find the interior ones, I'm going to find out what they would add up to using that formula 180 times n minus 2. I'm going to plug into that and get my answer, or get the sum, and then I'm going to divide by 45. For the exterior angle, well, we'll get to that in just a second. So I'll say 180 times 45 minus 2. So 180 times, that's going to be 43. This gives me 7740. So that's the sum. Now I need to divide it by 45 to get each individual angle. So I'm going to say 7740 divided by 45 equals 172 degrees. This is an interior. So we've done half the problem now. Now for the exterior, and this one's actually a little bit easier. 7.2 theorem tells us that the exterior angles always add up to 360. So here I just have to take 360 and divide by 45, right? It kind of jumps me down to the bottom step on the other side. So 360 divided by 45 gives me 8 degrees, and this is exterior. And there we are. Number 6. This one goes a little bit backwards in comparison to the previous one. Find the number of sides of a regular polygon with an interior angle measure of 156. So let's write down what we know. We have 180 times n minus 2. That gives me the total number of angles, or the sum of the angles. Now, if I were to divide this by the number of sides, then it would be equal to 156. Let's go back up to number 5 and think about that for a second. We started off by plugging into this, And then here at the end, we divided by 45. We could have done that all in one step. We could have done that all saying, we could have said 180 times 45 minus 2 over 45. We could have done that in one step. And that's what we're going to have to do with number 6 here, okay? So here we have this. This is our equation, and now we just have to solve this. Let's start off by multiplying everything by n. So I'm going to have 180 times n minus 2 equals 156 n. I'm going to distribute my 180 on the left. So I have 180 n minus 360 equals 156 n. Next up, I'm going to subtract this 180 n. So I have 156 minus 180. That gives me negative 24. So I have negative 360 equals negative 24 n. Now 360, or negative 360 divided by negative 24 gives me 15. So it's a 15 gon, or it's 15 sides. All right. And number 7, find the number of sides for a regular polygon with exterior angle measure 9. So what this is saying is we take 360 divided by the number of sides, and we got 9. Right? Let's look back up at number 5 and see what we did here. Here, it was a 45 gon, and we divided by 45. Right? Now we don't know how many sides it is, so we're just going to divide by n. So here I'm going to multiply by n to start off with, so I have 360 equals 9n, and then I'm going to divide by 9, so I have 360 divided by 9, and that gives me 40. 40 equals n. So it's 40 sides, we'll say a 40 gon. All right, that is that. These go over most of your homework problems, and if you have any problems, shoot me an email.